Hello everybody, my name is DePoalo and I'm the Partner Products Manager, and today I wanted to take a look at some projection toolpaths and different ways you can accomplish this. This is part of a series. I'm going to move all the way up to multi-axis surface projections, but to start off with I wanted to cover some 3-axis options that you have. Then we'll get into indexing, wrapping, and rotary. Okay. Now to begin with, I have an IGES file that I downloaded from BobCAD, which gives me a handle, and what I want to do is I want to put a checkered pattern into this handle using a V-tip cutter. So the first thing that I've done is I've kind of just isolated the handle. This is the surface that I want to work with. One of the things that came up recently, and this is kind of a good example, is if you have a surface that has some holes and you want to fill those holes, one of the things that you can do is you can go to untrim surface, and what that will do is break that surface down to the original geometry that made up that surface. So really, this is the surface that we would want to use. This way, it doesn't have any holes or anything in it. And what we're going to do is we're going to take. I have a boundary here. I just offset the knife's profile, and then I created a hatched pattern. And I want to take this pattern and I want to project it onto the top of this surface. So that I have some wireframe that I can use for 3D engraving. So in order to do the projection, I'm going to create a new layer, make it active. I'm going to go to surface, other, project curves on the surfaces. I'm going to select by color. In this case, I'm going to go pick by color, and I want the brown to go on the surface. And now you can see how we were able to take our brown geometry and we were able to project that onto that curved surface. Now from here, you know, we're basically ready to machine. So I'm going to run this through the stock wizard and get a stock box around the part. For simulation purposes, I'm just going to run a 3-axis planer on this just to give us this contoured surface. I'll just compute that. If you've had this come up before, it's kind of good. You can notice that my 0 is located at the bottom of the part. And when I go to compute this, it's going to tell you, warning, the value defined for top of part is below the machine maximum Z value. In other words, your 0 needs to be above the part, unless if you come in here and change what your top of part setting is. What I'm going to do is I'm just going to change my origin to be top center. And I'll just reselect my geometry and recompute, and that should eliminate that. Alright, another thing that we'll notice is the toolpath is not rolling over the top of the surface. It's kind of just staying on the surface, but it's not going down over the edges. There's an option in here under cutting extents. We're going to go to part bottom, and that will just roll it all the way over to the bottom, which is fine for this example. I just wanted to get some toolpath on there so when we simulate it we can see what's happening. Okay, so now what I want to do is machine this. So I'm going to do a 3-axis engraving routine. I will select all my geometry here. I'm going to go to my tool crib, and I'm going to grab a V-tip cutter. Really, any of these will work fine for this example. Parameters, I'm going to say 0.01 should be fine, and compute. And what that will do is just cut this pattern into this blade here. So this handle. Let's go ahead and load up the simulation. Now, real quick, one of the things that you'll notice about the simulation is any of the solids that were on the screen or in your drawing screen will pass through. So I can just turn my solids off, so I'm looking at my geometry. I'm going to trace my toolpath. I want to advance to op number 2, so I'll just click on op number 2 and let it run through the simulation here. And this gives us our handle, you know, from our planar toolpath. And now I just want to slow this down, and we'll be able to see our projected toolpath being generated. Now, you can project your toolpath down onto the surface. Because I use the pattern that a crosshatch in order to generate the geometry, it will follow through in the order that it was created. Sometimes you may just choose to use your toolpath boundary and run a planar toolpath with an engraving tool like this, or a V-tip cutter, which would give you the same result. Again, this is one example in which you can use to project toolpath, or types of toolpath projections, and the way that that works. So we can see how this is going to create our crosshatch checkering pattern across this contoured surface. In the next video that I pick up, I'm going to look at ways that you could do different ways that you could use projection toolpaths using, you know, maybe your fourth axis, and how you could put a projected path down onto an angled surface and be able to wrap that using wrapping groups. But we'll pick that up in the next video. Hopefully you guys found this information useful. You know what? There's one other thing that I'm going to cover real quick. Here we can see the pattern that we created. The other thing that I wanted to cover is sometimes you may want to step your toolpath down in Z, and we until recently didn't really have an option for the 3D engrave, which is really like a manual toolpath. But now you can do a translate, and you could say number of copies, 3 copies, Z 0.001 as an example, and click OK. And now what that will do is step that routine down in Z. So again, another very useful feature, just kind of covering more information there, and we'll pick up this example and others examples here shortly. Thank you so much, guys.